Welcome to question 6 of the 2006 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. The probability density function of a continuous random variable x is given by f of x equals x over 12 between 1 and 5 included and 0 otherwise. For part A, we're asked to find the probability that x is less than 3. So to find the probability that x is less than 3, we can find the area underneath the probability density function. And the area is found by finding the integral between the lower bound of 1, because that's the end point here, and 3, because that's what we want it to be less than, for the function x on 12 with respect to x. And if we find the antiderivative, that's the same as adding 1 to the power and dividing by the new power, so it will become x squared on 24. I'm going to evaluate that between 1 and 3, which is the same as the antiderivative evaluated at 3, subtract away the antiderivative evaluated at 1. So therefore, the probability that x is less than 3 is equal to x squared on 24 evaluated at 3 would be 3 squared on 24, subtract 1 squared over 24, which equals 9 over 24, subtract 1 over 24. So that is equal to 8 over 24, and in simplest form, that is 1 divided by 3. So the probability that x is less than 3 is 1/3. The examination report indicates that about half of the students received full marks for this question, and the main difficulty was with students determining which terminals needed to be used, so the lower bound of 1 and the upper bound of 3. The majority of students knew the required antiderivative, with an exception of a small number who obtained log e of x. So that misconception there results from the antiderivative of 1 divided by x. It was disappointing when students failed to include the dx as part of their integral expressions, and that will be penalised in the future. A small number of students used 3 and 5 as their terminals and then subtracted their answer from 1, which would also give the correct value. Even fewer determined the required value by using a graph and finding the area of an appropriate triangle. So if we have a look at what that method would have looked like, you would have had the graph of f against x, and the graph is a linear line, but it only starts at 1 and goes until 5. So this value here is 1, and this value here is 5. And that would have coordinates 1, 1 on 12, and this would have a coordinate of 5, 5 on 12. And elsewhere, the graph would have been 0. So that would have been the full graph if you had sketched it. And now it was asked for the probability less than 3, which equates to this shape here, which is a trapezium, and finding the area of that. So the area of that trapezium is equal to a half, and then we add the two side lengths that are parallel, which is 1 on 12 plus, and this point here would have coordinates 3, 3 on 12. So plus 3 on 12, and then we multiply it by the length of the trapezium, which is 2. So that area is equal to half times 4 on 12 times 2, and if you evaluate that, you get that's 4 on 24 times 2 is 8 on 24, which is the same 1 divided by 3, which was found using the method of integration on the previous slide. For part B, we have the same probability density function, and this time we're asked that if x greater than or equal to a equals 5 on 8, find the value of a. So once again, we can use the area under the curve to evaluate this, so a being the lower bound and 5 being the upper bound, being here, of x over 12 dx must equal 5 over 8. Another way of putting that is that the antiderivative x squared on 24 evaluated between a and 5 must also equal 5 over 8. So we find that the antiderivative evaluated at 5 would be 5 squared on 24 minus a evaluated, which would be a squared over 24, equals, and we'll get the common denominator of 24, so it would be 15 over 24. Therefore, 25 minus a squared must equal 15. Therefore, we find that a squared must equal 10. Therefore, a equals plus or minus the square root of 10. However, if we look back at this domain, we know that a must be between 1 and 5. Therefore, a can only equal positive square root of 10. So that is the answer for part B of this question. So from the examiner's report, we can see that about 40% of students got full marks for this by evaluating one of those integrals. So the one we did, or an alternative one, would have been between 1 and a of x over 12 dx equals 3 on 8. And a large number of students were able to set up the correct integral equation, but then they were unable to solve it to find a. Another incorrect response was including a equals negative root 10, which was outside of the domain, and that should be avoided when you've got this style of problem.